Alright, welcome back. So today we're going to be looking at line graphs, and line graphs are great because they help us find out trends and patterns in data, and we can see how they track changes in values over days, months, weeks, years, minutes, or seconds, and use this information in order to make great decisions. So let's get started with our first one. We have ice creams sold, and we have down the bottom we have the days of the week, and up the side here we have our amount sold, or our total sold during that particular day. Alright, so let's start with question A, and it's asking us on which day were the most ice creams sold. So the higher we go up the vertical axis, the more we have sold, and our highest point is right here on Saturday, where we have sold 40 ice creams. So Saturday is our first answer. For B, we're looking at on which day did sales drop the most compared to the day before. And when we're looking at large drops in sales, we have to just consider the vertical distance between one spot and another. So if we look at this particular distance here, we can see that we have 25, 26, 27, 28, it looks like here. So we've gone from 40 to 28. So our first little investigation is going to be 40 minus 28, and that's going to be 12. So we've dropped 12 between our Saturday figures and our Sunday figures. And then our other major drop is between Wednesday and Thursday. So let's just look at what this particular drop is going to be. So up here we have 30, and down here we have 21, 22, it looks like, so 22. So here we've dropped 8 between those two. So our largest drop is in fact from Saturday to Sunday. Alright, let's continue onwards. Let's look at C. So we have the most, what were the sales like on Monday? Well, on Monday we sold 20. So we had 20 sales, but what it's asking is whether they're best, whether they're the worst, and 20 sales, which was the worst of the week. Okay, so we've used this information to interpret the data and interpret our sales, and now we can see that our worst days are going to be on Thursday and on Monday, and we have the largest drop-off on Sunday. So what does this tell us? It probably tells us we don't operate on Monday, we don't operate on Thursday, and on Sunday we might have a reduction in the amount of staff or the amount of hours we're actually open. Alright, welcome back. So now we're going to be looking at an example that you guys can do. So just give the video a pause, give it a go, and then I will solve the questions and give you the answers. Alright, let's get started. So up the top here we have our speed in kilometers. So this is the speed our runner was going, and down the bottom we have not hours, we have time, we have minutes. Alright, so he's gone for a 40-minute run, and we have the various different speeds he's going at different time intervals. So our first question A is, what was the jogger's speed at 10 minutes? So if we go to 10 minutes, we can see that up here he was going at 6 kilometers per hour. If we look at B, we have during which time was the jogger running the fastest. So obviously the higher we go, the faster he's going, and he's running his highest between these two points in time here. So between 15 and 20 minutes he's running his fastest at 7 kilometers an hour. So between 15 and 20 minutes. Alright, for C, when did the jogger slow down? So all through this period here he's speeding up, but he starts to decline immediately following this point here at 20 minutes until eventually he gets down to 40 minutes and it's at 0 kilometers an hour and he's come to rest, he's stopped, or he's decided not to do any more running. So it starts to decline after 20 minutes. And finally D, estimate the jogger speed at 8 minutes. So one of the things we can do is, even though we don't have data at 8 minutes and we only have data for every single one of these major points, we can use the line to estimate what it would be like at 8 minutes. Now we're going to have to estimate our time here. So halfway between 5 and 10 is about 7.5. So let's move them a little bit further across, and then we're just going to draw a line up to the graph and decide what we think that speed is right there. Now if we go across to the vertical axis, we can see that's just above 5 kilometers an hour. So we might say this is about 5.2 or 5.3 kilometers per hour. And remember, it's an estimate, so it's not going to be exact. And additionally, the fact that this data doesn't include any subdivisions of the speed makes it harder to know what that estimate is. And even though we have some rough idea of where 8 minutes is going to be on our timeline down here, it's also not going to be particularly accurate either. Alright, that's it for this video. So hopefully it was helpful, and I will see you in the next one.